Good morning, everybody. My name is Kevin. Welcome back to the ESP32 product creation journey and a rare early morning stream here, but I've just been slacking. I have not been able to get this stream recorded, but I'm going to share today, fingers crossed, the for real way to get debugging working with your ESP32 device in VS Code using ESP-Prog debug module. So that's what we're going to talk about today. I'm not going to waste any time. We're going to get right into it. From my last stream, I decided the best way to do this would be to create a repo that other people could just clone to get started. But also, if you already have an existing project, you wouldn't want to clone the project. You would want a way to maybe incorporate the things that you need into it. So here it is. I will put a link in the description below. It is this ESP-Prog VSCode debug sample repo. And so how to use this repo. So for a new project, which is what we're going to do today, we can just clone the repo directly, use it as bare bones to, base to build on top of, and then we just follow the instructions under setup and configuration. If you already have a project, that's okay. The magic is really just in these three files that are in the VS Code folder, the launch.json, settings.json, and task.json. And so you can incorporate pieces of those into your existing project. I mentioned that if you already have a launch.json, that's probably because you've tried to get this to work and have failed. Otherwise, you probably wouldn't be watching this video. So I would highly recommend you just simply replace it with the launch.json that I have here in the repo. As of April 2021, this is the way that I have gotten this to work reliably, repeatably, and there's lots of information on it on the internet of different ways. This has worked for me. And so let's come down to the setup section here. There's a few things that you need to make sure that you have ahead of time. And so I'll launch a terminal window as we're reading through this here. The first thing it says is we need the ESP IDF repo. You probably already have this on your machine. All you really need to know is the path for that. So in my case, if I just go to cd home dev ESP IDF, this is where I have ESP IDF installed. You can see that I am on version 4.2. These instructions, currently the repo is specific to version 4.2 because the version of all the tools is very specific to version. So if you're on a different version, you're going to have to change some paths that I'm not going to get into in this video, but I can try to remember to briefly touch on that. So, okay, great. Next, you need the Esp Idf Tool Chain. There's a little handy link here. You click on that. If you don't, you probably already have it installed, but it takes you to the setup the tools here, and you have to install the tools, Windows, Linux, and Mac OS. The instructions here for Windows are probably going to be a bit different. So I use Linux personally. This would probably be almost identical on Mac if you're using Mac, but just be aware of that. Python 2 dependencies, okay? Hours and hours figuring out all the corner cases and quirks of this. Even though you may be running Python 3 and you may have configured the tools and ESP-IDF and all that to use Python 3, there are still, you can see I linked an issue here due to some issues with Python versions and the ESP-IDF tooling. You must have, at least as of right now, April 2021, you need to have the Python 2.7 dev libraries installed on your machine. If you want more information about that, check out this GitHub issue that I linked. Eager, awesome in the chat, has explained on this thread like the complications of why this is necessary. And what's really crazy about this is, at least in my case, it manifests itself as just silently failing. So like the builds just didn't work. And so this one took me a while to figure out. To fix that, Mac and Linux, you just sudo apt-get install libpython 2.7 dev. Pretty simple. I'm going to, this is a problem with streaming in the morning. My kids are awake and streaming music in the other room, and you probably can't hear it, but I can hear it, and it's way too loud. So give me just a moment. Using the power of technology, I'm going to crush their hopes and dreams by turning it down. 100%. It's always 100%. Kids turn it up to 100% every time. So I'm going to do that. Okay. Okay, so you need the Python 2 dependencies. Great. Thorhax, hey, thanks for joining. A little morning stream here, going through setting up debugging. Okay, so let's move down to, well, sorry, before we get into the configuration section here, let's clone this repo as a starting point. So I'm going to come up here, I'm going to grab the code, and then I'm just going to come into my downloads folder, downloads, and I created a temp folder just so that you can see there's no smoke and mirrors. There's nothing in this folder. And then we'll do a git clone. Oops. All right. And then, well, we don't need this window anymore. Okay. So now we can come down to the configuration. And I'll just walk us through these changes. The three files, task.json, you shouldn't really need to modify unless you have an existing project, in which case you can supplement your task.json with the things that are in the repo here. And so let's come over here and let's open that up. Open folder, go to dev, whoa. Not dev, downloads, temp. This is what we just opened. Great. All right, here we go. We're all set up. Very simple shell project here. And what I'm going to do is I'm going to grab the instructions and pull them over because I'm just going to walk through them like you would at home. And it helps me talk through it. Okay, so this is a very simple project. Let's just look at it real quick. It has one file, main.cpp, and all it does is print debugging in VSCode on a 1 second delay, just every 1 second. And just very quick side note, I love this style, using just the standard C++ libraries instead of the VTAS delay stuff. You can do this, you just include thread and chrono, and you can do standard this thread sleep 4 chrono seconds or chrono minutes or chrono hours. Really super handy. I love the way it reads. Anyway, that's our program. Nothing complicated, just to get started. Okay, the first thing we're going to do is we need to notice that we have this .vscode folder. Now, if you've done anything in your project to configure something around VS Code, you likely have a .vscode in your top level project. If not, just create it. And we've got three files here: launch.json, settings.json, task.json. We're going to start in settings.json. And this is just where we can define a bunch of variables, essentially config variables that we can use in the other files. And I'm not going to get into a lot of the specifics of this, just know that these work. If you want a deeper dive, let me know. We can maybe do that in another video. But the instructions say replace all instances of ESP IDF root with the fully qualified path of where you cloned the ESP IDF repo. And so I make a note in here. A quick way to do this in VS Code is just highlight this right here and then do Ctrl D. And it'll highlight every instance of it in the file as you keep hitting Ctrl D. You can see there's only 2. And then we're going to replace it with our root, which in my case is /home, Kevin, dev, ESP IDF. Okay, great. And then it says ESP Tool Chain root. The instructions say replace that with the fully qualified path of the top level directory containing the ESP IDF Tool Chain. And so let me open a prompt here really quickly. If we look into the directory of .espressif, this is where it installs it by default on Linux and Mac. It'll be in like the user root on Windows. If we look at that, you can see that we have a dist, Python, env, and tools. What we want to, the ESP tool chain root is this path right here. It's not the tools path, even though it says tool chain. And the reason I say this is highly version specific is because if we come into the tools folder and then just pick one, like let's pick the Extensa elf. And then you see that the next folder down has this 2020 R3-8.4.0. Every time they rev the IDF, you get different values of these tools. And as you'll see in the settings file here, it's highly dependent on those versions. And so if you look at this, these versions are all baked into these paths. And so if you're not on version 4.2 and you're watching this video, it's likely that you would have to make changes down to these paths here with all these different versions that are in here. So, okay, but back to the instructions. ESP Tool Chain root, we're going to replace with our root, which in my case is home kevin.espressive, not tools. And you notice there's no trailing slashes on these. And I didn't replace all of them. So let's Control Z that. Okay, again, highlight it and then just go to town, pressing Control D. You can see it's highlighting everything. And once you've gotten them all, it'll pull you back up to the top here. And so now if I start typing, it replaces it everywhere. /home/Kevin /.espressive. Okay. And that changes it all down through here. So all your paths are correct. Great. Okay, launch.json. If you've just cloned the repo, you don't have to make any changes here. The one thing of note, however, in this file is the target. So what it needs for debugging is it needs the path to the .elf file. This will be created for you when you build your project. And the name here, ESP-Prog VSCode debug, is created based on, in your CMake list, what you called your project. So again, if you've cloned the repo, you don't have to make any changes. But if you're implementing it in your project, you will likely have a different, for sure, have a different named elf in your build directory. You just need to change that path here so that the debugger knows where to find the elf file. Okay, everything else in here is like the magic of lots of trial and error of making everything work. Okay, so launch.json. And then task.json, we don't need to change. If you already have a task.json, this just has a bunch of very handy tasks that you can run, like building firmware. The OpenOCD one is part of the magic of making this all work. Flash and monitor device, flash device, monitor device, clean project. So these are just, you can actually, if you already have a task folder, you can just grab all of these entries and just paste them into your tasks array, and they'll just be added to your environment. So those are all the changes that you need to make to the VSCode files. All right. With that done, we are ready to try debugging. And so let's get a clean terminal down here. Okay, and so there's a section, debugging instructions, and there is a note at the top, and it says, one thing I encountered was both the ESP32 target device as well as the ESP-Prog will enumerate as dev TTY USB 0 if plugged in first on Linux. This is on Linux. I imagine it's similar on Mac. I have no idea what it's going to look like on Windows. And since the debug commands rely on a specific target, so back here in the settings, we have a default of dev TTY USB 0. If it's different on your machine, you can just change the device port here. The baud rate, you probably don't need to mess with if you're just using a dev board or other ESP32 derivative. Because it relies on this being fixed, it can't change. And so what I found is when I plug my device in first, it gets TTY USB 0, and then when I plug ESP-Prog in, it gets TTY USB 1 and 2. It's got two interfaces on it, I guess. And then, however, if I plug the ESP-Prog in first, it gets TTY USB 0 and 1, and then if I plug my device in, it gets TTY USB 2. So that's something you need to be aware of because, again, it's got to be fixed across. The commands need to know, and if you don't pass the port and baud, the tool tries to figure it out, but it almost always gets it wrong in my experience. And so down in these commands here, we are passing, where is it? Not in here. It's in the task.json. We are passing the port and baud rate to be explicit. Again, that's because the auto figuring it out doesn't really work when you have ESP-Prog plugged in my experience. So just be aware of that, and the instructions try to save you from this because I give you a specific order to do things in. So first instruction, it says attach the ESP ESP-Prog to your target device via whatever JTAG cable is required. So again, in my case, that looks like this. This is my target device, our e-paper display hardware that we're working on. I have this tag connect connector that I've talked about in the past, and then here is the ESP-Prog module. So that's step one. Connect these two things together. Okay, we're done. Step two, plug the target device, the one you want to debug, into your computer. Again, the order of this, at least in my experience, matters the first time. When you're first getting, you turn on your machine and you're first getting into your dev environment. If I don't do it in this order, I run into some weird errors. Not really sure what those are, but this has been fairly reliable, and I know now that I'm streaming it's not going to be reliable, but we're going to try it anyway. So it says plug it in to your target device. So I'm going to plug that in, and now that means our ESP32 device is running and doing its thing. Okay, step three, press Ctrl-Alt-T to open the task list in VS Code and select Flash and Monitor Device. So Ctrl-Alt-T is a shortcut. You can also come up to the Run menu here. Is it Run? No, it's Go. No, I'm lying. How do you do it? I always just use the, here we go, Terminal, Run Task. You can do this as well. I just prefer the shortcut Ctrl-Alt-T. If you do that, you can see it pops up the tasks, and here are all the tasks that are in tasks.json, and it says select Flash and Monitor Device. That's what our instructions say. So this is going to build our project, and now this is when you'll know if you've got everything set up correctly with the path. So I'm going to hit Flash and Monitor Device, and if it starts compiling, that means your paths are correct in your settings.json. So it's going to build our whole project. Remember, the first time through, it's got to build the entire ESP IDF framework. So that will be a one-time hit that makes the process take a little longer. All future builds will be iterative. They'll just build the things that changed. And so it's going to build it, and then it's going to try to flash it onto our device. So let's wait for that. It's almost finished. There it goes, connecting, it's programming. Let that cruise, check, see if there's any comments. Not yet. Okay, now that it is programmed, you'll see it says debugging in VS Code every 1 second. Great, that means our firmware is flashed onto our device and it is working. Okay, next step. It says the device, it's not really a step, and I don't know why I made it a step, it kind of bothers me, but step 4, the device should successfully flash and start showing serial output if applicable. And in our case, it is applicable, so we are seeing serial output. All right, now step 5, plug the ESP-Prog into your computer. The red LED should illuminate. Okay, I'm going to plug in my ESP-Prog. And the red light indeed did illuminate, and if I clear the output window here, you'll still see that our code is just running happily. It's just ESP-Prog is now plugged in. All right, step 6, which is the final step. Start a debug session with F5, run start debugging, or the other way. So you can either, you can come to the debug tab here and you can hit this play button. You can go to run start debugging, or old school, you can just hit F5 and it will start to debug. So I am going to press F5. And it's going to do some magic. The first time through, it will take a few seconds as OpenOCD starts up. You may get this message. The task OpenOCD cannot be tracked. Make sure to have a problem matcher defined. I don't mess with this right now, so I just say, remember my choice for this task, and I say debug anyway. This is not an error, even though you get a big scary exclamation point. Okay, you'll see the color change down here to like an orange to let you know you're in debug mode, and here we are. We have hit a breakpoint right at the start of our code. Now, we don't have a breakpoint here, but the way that this is set up is as soon as it connects to your device, it issues a reset and halt, which resets your device. And so if we come back over to terminal here, you can see now we have a new task, which is OpenOCD running. This will always be running while we're debugging. And if we come back to our flash and monitor device, you can see we stopped, like up here, we were looping through our debug in VS Code. But you can see this is a normal boot. It came up and now we're halted right here. It's not outputting anything because the debugger has reset our device and automatically stopped it for us at the top of our code. So that's it. We're in. We're debugging. I can use the toolbar up here to step over, step into, or the F10, F11 if you're used to the command line, not the command line, the keyboard. And so we're debugging. And now if I hit step over here, F10 for those that like the keyboard, it will step to the next thing, and you'll see down here that it printed out debugging in VS Code. I can put a breakpoint here like that, and then hit play again. It will wait a second, and then it's going to stop again. And so that's it. We're debugging. If we look at the instructions, we have a done. Like, congratulations, you've made it. One thing to remember, and I put a note in the instruction, is you have to remember to flash. If you're used to a typical like software IDE, you make code changes and then you hit debug, it sort of builds, it saves, it builds, and then you're debugging that new code. That does not happen here. You have to make sure that you have flashed the new code. So anytime you make changes, you need to make sure that you flash the code again before you debug. And the flow is a little bit different as well, because debugging is, in software, debugging sort of its own, like you make changes to code and then you start debugging. Like you can be in a debug session, but also have code or have the code running outside of debug. With the hardware, it's a little different because you have this connection between them. So just remember, when you want to make code changes, just remember to stop it. There's a stop button here. This toolbar, depending on the theme you have in VS Code, can get a little lost sometimes, but make sure, and that's why I think they have the color difference as well to help you know that you're in debug mode. So what I'm going to do now is watch. I'm going to hit stop to stop debugging. And in the case of like software, like your program closes and shuts down and everything, and that sort of happens, but not really. So I'm going to hit stop. The color goes away, but you can see it still says debugging in VS Code. The target device stays in like a halted state on that breakpoint that we had set where we were debugging through. And so if I just hit the reset button on it, you'll see now it'll reset and it'll go back to running the code. And it's fine for the code to be running. At any point, you can trigger a debug session. Again, it will reset your device, halt it at the top, and you are ready to go. Okay, let me check, see if anybody has any questions. Nope. Okay, moving on. I have a little "it stopped working, now what" section in the instructions. Now, I found this to be very reliable. I haven't had a lot of issues. However, occasionally things will stop working and it won't be entirely clear why. And as I say in the instructions, the old turn it off and back on again is pretty effective here. So to fix almost anything, I'm going to show you a little bit about what's going on under the covers. So you've got your device. You have VS Code. VS Code can't talk directly to your device, nor can it talk directly to the ESP-Prog, which is talking to your device. And so for that, we need OpenOCD, which allows us to talk to the programmer, which is talking to the device. And that is why we have this task over here, OpenOCD. And it's always running, and you shouldn't have to ever manually do anything with it. If you see, if we do Ctrl-Alt-T, there is this OpenOCD task. You should never have to run that manually. The debug step should do it for you. But anyway, it's running, and what you need to do sometimes, I say this will fix most things, is you need to find this task window, give it focus, and then just hit Ctrl-C to kill it. And then start a debug session over. That should solve almost all problems. Another thing that I mentioned just again is that if your dev TTY USB 012 gets mixed up, it's going to get confused and you might get some strange errors there. But so remember to flash your code. Keep an eye on OpenOCD. If you're having issues, you just terminate it and run it again. It's not a big deal. And otherwise, you should be good to go. Now, the one other thing I want to show is what's really nice. So it's great. We can step through the code now, which is really cool. But also, if you come to the debug tab, like I have here, you've got this variables watch. Like you can do pretty much the same things you would do debugging regular software. So I'm going to write some additional code here. I'm going to say int I equals 0. And then I'm going to get rid of some of these exclamation points. And then do %d, and then we'll pass in I, and then do I++. So we're going to say debugging VS Code, and then a number that increases over time. So great. Remember, I can't just hit debug here. I need to make sure I'm flashed first. So I'm going to save that. I'm going to do Ctrl-Alt-T. I'm going to say flash and monitor device. Now you're not going to see it because it's going to be behind my face here. You get a little message that pops up in the bottom. Let me just hide myself so you can see it. You're going to see a little message pop up in the bottom corner that says that task is already running. What do you want to do? And we just want to restart it. So I'm going to go ahead and do Ctrl-Alt-T. Where are we at? Ctrl-Alt-T. And I'm going to say flash and monitor device. I don't know why it didn't like that. Let's try that again. Flash and monitor device. There we go. The is already running. I just want to hit restart task. It's going to restart. It's going to build, and then it's going to flash again. Let me bring me back. Okay, it's writing that. And so now let's take a look at what we get here. Okay, and again, 0, 1, 2, 3, 4. Pretty cool, right? All right, now let's start a debug session. What am I going to do? This time I'm going to hit the play button up here to show you that there's different ways to do this. Go ahead, and again, it kicks you into the top of your code, automatically stopping at the top. Again, it didn't even make it to our breakpoint yet. So I'm going to hit play. Now it's going to stop there, and let's go back. Well, no, let's stop here for a second. You can see variables local, like it has my local variable I. If I want, I can add watch variables just like you would. Just hit I. Pretty cool. It shows it there. And so let's hit play. It's going to go through, and nice. Now I is 1, and I'm on the next line. I got this VS Code. Debugging VS Code is 0. You can even do some really cool, fancy stuff that I just learned recently, which is let's right here, let's right click, and instead of just doing add breakpoint, let's do add conditional breakpoint. When do we want to stop here? Well, let's stop here when I is 10. And you can see I don't know how well you can see, but the icon for the breakpoint is a little different. And I'm going to remove this breakpoint, and then I'm going to let it play, and let's see what happens. You're going to see it's going to skip, and now I've got the output down here, 3, 4, 5. And then when I is 10, it's going to break. That's a huge, oh, or not. What did I do wrong there? Add conditional break. It might be because it's, let's do this. I equals equals. Did I do equals equals before? All right, let's disable that breakpoint because it's on the sleep. All right, what are we going to do here? I'm just going to reset it. Restart. Boom. It should restart my device. Hits the breakpoint at the top. I'm going to hit play. VS Code. We should hit this break. I was just testing this last night. And it should hit the breakpoint when we get to 10. There we go. I don't know why I didn't like it down here on the sleep 4. But so now you can see it's broke. I'm at VS Code 9. And that's because it's about to print out 10, because that's what I is equal to now. So some pretty cool stuff. You have the full, debug experience in VS Code. I really love this call stack over here. It will show you all of the tasks, the free RTOS tasks that you're running over here. And so you've got the call stack. It'll show you. So if you have functions and stuff, you can step into functions, step out of functions, step over. All the normal debugging stuff should now work for you. Again, always remember to flash. Always remember to stop the debugger. If you need help or if something's not working, reset this OpenOCD task, and you should be good to go. Debugging in VS Code on your ESP32 works like a champ. Okay. So that's, like I said, all I want to do is hop on the stream this morning to get that recorded. I will put a link to the repo in the description as this goes up on YouTube, so that hopefully it can help other people. I've had a lot of people ask me about this, and again, it should work just fine. Just as a final quick note, we'll go ahead and hit stop there. Again, in your settings.json, if you're not using 4.2 of ESP Idf, These paths are almost assuredly going to be different. All you really need to do is, if you want to hand edit it, is cd over into your, it's probably easier to look at it in the GUI file explorer, but dot expressif, we'll cd into tools, and you have a bunch of different tools here, and you can see which ones we use. Like, for example, OpenOCD ESP32, the version 0.10.0 plus a whole bunch of things. So if I just cd into OpenOCD 32, there's the version. And so if you are on a different version of ESP IDF, you can come into this tools and then just look at whatever the version of yours is, copy that there and replace it. There's a little bit more handwork. For me right now, for our product that we're working on, I'm on version 4.2. I will make a decision of whether to move to 4.3, but if I do that, I'll obviously update and create a tag on the repo so that people can check out different versions of that. Right now, it's a single version thing. It's 4.2. So that is going to do it for the morning stream. I know I've said I'm going to stream in the evenings, and I haven't the last several days, but tonight I am really, really going to try to be back on. This was a kind of a distraction, not what I wanted to spend a bunch of time on. But again, I want to help people, and a lot of people need help with this specifically. But tonight, we're going to be back on working on the project, and I'm not going to show it now. I got some stuff, like exciting things I'm excited to show. I'm really pumped about that. So that's going to do it. Thank you so much for watching. I hope that this helps you. If you have any questions, stick them in the description. Not in the description. You can't stick anything in the description. Stick them in the comments below, and I will do my best to help you out. So thanks so much, and have an amazing rest of your day.